Question 1. For each core responsible AI principle, drag it to the appropriate box in the correct match column to match it against its universally true definition or example in the option column. Treat all people fairly. Avoid bias that advantages or disadvantages groups. Fairness. Perform reliably and safely with rigorous testing and appropriate confidence thresholds. Reliability and safety. Protect data and customer content with appropriate safeguards. Privacy and security. Empower everyone and include diverse input in design, development, and testing. Inclusiveness. Be understandable. Make users aware of purpose, limitations, and confidence in predictions. Transparency. Ensure people and organizations are answerable for AI systems within clear governance. Accountability. Unused items. Cost efficiency. Performance optimization. Now let's work through why each match is correct and why the unused items don't fit. Fairness is correct because it focuses on preventing biased outcomes across different groups. For example, ensuring a hiring or loan model does not systematically disadvantage a protected subpopulation due to unrepresentative training data. Reliability and safety is correct because AI systems need rigorous testing and confidence thresholds to reduce unsafe behavior. For example, a model might refuse to take an automated action when confidence is low and instead route the case to a human reviewer. Privacy and security is correct because AI solutions can handle sensitive customer data, so controls like restricted access, encryption, and secure storage protect that data from leakage or misuse. Inclusiveness is correct because involving diverse users in design and testing helps ensure the system works well for people with different needs and backgrounds. For example, testing with varied accents, languages, or accessibility requirements reduces exclusion and improves usability. Transparency is correct because users must understand what the system does, its limitations, and how confident it is. For example, sharing intended use, known failure cases, and confidence indicators helps users interpret outputs appropriately. Accountability is correct because organizations must be answerable for AI outcomes under clear governance. For example, defining owners, audit processes, and escalation paths ensures issues are tracked and corrected responsibly. In contrast, cost efficiency is a business optimization goal and not a core responsible AI principle here. Performance optimization focuses on throughput or latency tuning and does not define ethical or governance safeguards for AI behavior. Question 2. For each tool or component in Azure-based development, drag it to the description that is a universally true match. Package used to install Python libraries from the Python package index. Pip. Object that provides a programmatic proxy to work with a specific AI project. AI project client. Credential helper that discovers tokens from the environment to authenticate with Azure. Default Azure credential. Command to sign in so that subsequent SDK calls run in an authenticated Azure session. AZ login. Core Python library that enables connecting to a project and accessing its defined resources. Azure AI projects. Unused items. REST API. Azure OpenAI Service API's endpoint. Azure AI Services API's endpoint. Now let's work through why each match is correct and why the unused items don't fit. Pip is correct because it is the standard Python package installer used to download and install libraries from PyPI. So it directly matches the package installation description. AI Project Client is correct because it acts as the client object you use in code to connect to and interact with a specific Azure AI project, which is why it fits the programmatic proxy description. Default Azure credential is correct because it automatically attempts multiple credential sources and discovers an available token from the environment, such as a signed-in developer session or managed identity, to authenticate SDK calls. AZ login is correct because it signs you into Azure through the CLI and establishes an authenticated session, which SDK tooling can then use to access Azure resources under your account. Azure AI Projects is correct because it is the Python package that provides the project-related SDK surface, enabling connections to a project and access to the resources defined within it. In contrast, REST API refers to the HTTP interface pattern for making requests, not a specific installable package, client object, or credential helper. Azure OpenAI Service API's endpoint is just a service endpoint reference, not a tool component like a library or credential. And Azure AI Services API's endpoint is also an endpoint type rather than a client package or authentication utility. Question 3. Fill in the blanks by selecting the correct options from the drop-down menus. During initialization, planning includes understanding what typical inputs look like, how those inputs will be presented to the application, and how the application will generate the desired output. Now let's work through why these selections are correct. The first blank is what typical inputs look like, because early planning requires clarity on the kind of data the system will receive, such as text, images, or structured prompts. So the solution is designed around real input patterns. The second blank is presented to the application because planning also focuses on how those inputs flow into the system, for example, through an API request, user interface, or automated pipeline, ensuring the application can reliably consume them. The final blank is generate the desired output, because initialization must account for how the application transforms inputs into useful results, such as predictions, responses, or classifications, aligned with the project's goals. By contrast, options like model training objectives, endpoint scaling policy, random sampling, or offline batch export relate to later optimization or operational concerns, not the core initialization planning focus described in this question. Question 4. For each statement below, indicate whether the answer is true or false. Connections let users reuse authorized access to external services across tools. True. Necessary secrets in connections are not exposed to users and are stored in Azure Key Vault. True. Runtimes provide a controlled environment for running and validating flows. True. A default environment is available for quick development. Create a custom environment when extra packages are needed. True. True. Now let's work through why each statement is true. The first statement is true because connections act as reusable authorization links, allowing multiple tools or nodes to securely access the same external service without reconfiguring credentials each time. The second statement is true because sensitive information such as keys and tokens is never exposed directly to users. Instead, it is securely stored and managed in Azure Key Vault, protecting secrets from accidental disclosure. The third statement is true because runtimes define a controlled and consistent execution environment, which ensures flows can be run, tested, and validated reliably under known conditions. The final statement is true because a default environment supports rapid development out of the box, while custom environments are intended for scenarios where additional packages or dependencies are required, providing flexibility without slowing early development. Question 5. Fill in the blanks by selecting the correct options from the drop-down menus. When a model generates answers using only the information it was trained on, the result is called an ungrounded response. In contrast, when the model uses external factual data to inform its output, it produces a grounded response. Now let's work through why these selections are correct. The first blank is ungrounded response, because the model is relying only on its general training data without checking or referencing any real-world or external source, which means the answer may sound confident but is not anchored to verified facts. The second blank is external factual data, because grounding requires pulling in information from trusted sources, such as documents, databases, or APIs, to support and validate what the model generates. The final blank is grounded response because combining the prompt with factual, contextual data improves accuracy, reduces hallucinations, and ensures the output reflects real and verifiable information. By contrast, terms like contextual model, fabricated prompt, predictive grounding, or language bias do not describe the response type or the grounding mechanism being tested in this question. Question 6. For each statement below, indicate whether the answer is true or false. Standalone Azure AI resources often provide a free tier SKU for evaluation. True. Azure AI Face service is unrestricted and available to all customers without approval. False. Provisioning Azure AI resources can be done through the Azure portal, Bicep, or ARM templates, or the CLI. True. Regional availability is consistent across all Azure AI services and models. False. Now let's work through why each answer is correct. The first statement is true because many standalone Azure AI services, such as Vision or Language, include free tier SKUs, which are designed to support experimentation, learning, and early evaluation without upfront cost. The second statement is false because Azure AI Face includes sensitive capabilities, and some features are restricted, requiring approval to ensure responsible and ethical use. The third statement is true because Azure AI resources can be provisioned using multiple methods, including the Azure portal for manual setup, infrastructure as code tools like ARM or Bicep for automation, and the Azure CLI for command line workflows. The final statement is false because availability varies by service and by region, and not all Azure AI services or models are deployed globally, which means regional support must always be checked during planning and deployment. Question 7. What is a benefit of using a multi-service Azure AI resource compared to standalone services? Select one answer. A. Each service must be provisioned individually with separate endpoints. B. It eliminates all costs associated with using AI services. C. It provides a single resource that encapsulates multiple AI services with one endpoint. D. It guarantees unlimited regional availability for all included services. The correct answer is C. It provides a single resource that encapsulates multiple AI services with one endpoint. Now let's work through why this answer is correct and why the others are not. Option C is correct because a multi-service Azure AI resource groups several AI capabilities under one resource, exposing a single endpoint and key, which simplifies management, configuration, and integration when an application uses multiple AI services. Option A is incorrect because provisioning each service separately with different endpoints describes standalone resources, not the advantage of a multi-service setup. Option B is incorrect because using a multi-service resource does not remove costs. Usage-based pricing still applies based on how much each service is consumed. Option D is incorrect because regional availability is still constrained by service and region, and a multi-service resource does not guarantee unlimited or global availability. Question 8. A technical writer wants the model to produce structured release notes following a company-style guide. They provide a single example release note in the prompt to illustrate tone and formatting before asking the model to generate a new one. What prompting technique are they using? Select one answer. A. Chain of thought reasoning. B. Persona prompting. C. Few shot prompting. D. Reflection prompting. The correct answer is C. Few shot prompting. Now let's work through why this answer is correct and why the others are not. Few shot prompting is correct because the writer gives the model one example, which teaches it the expected structure, tone, and formatting, allowing the model to imitate that pattern when generating a new release note. Chain of thought reasoning is incorrect because it focuses on asking the model to explain its reasoning process, not on learning output style from examples. Persona prompting is incorrect because it assigns a role or perspective, such as acting as a specific job title, rather than demonstrating a formatting pattern through examples. Reflection prompting is incorrect because it asks the model to justify or review its own answers, not to replicate a demonstrated structure or writing style. Question 9. Arrange the production flow activities in the correct order. Instruction. Drag and drop the items into the correct order, starting with the first step at the top. Optimize the flow using variants. Deploy the flow to an online endpoint. Monitor key metrics and feedback. Now let's work through why this order is correct. The first step is optimize the flow using variants. Because before exposing a flow to users, teams experiment with different configurations, prompts, or components to improve quality and performance. Next comes deploy the flow to an online endpoint, because once the flow is optimized, it must be made available through an endpoint, so applications or users can start consuming it in a production setting. Finally, monitor key metrics and feedback, because after deployment, it is essential to track usage, performance, and user feedback to detect issues, validate outcomes, and decide whether further optimization is needed. This sequence reflects the natural production lifecycle: tune first, deploy second, and continuously monitor afterward to support ongoing improvement. Question 10. A knowledge assistant must retrieve relevant material from English and Spanish documents and from product images with descriptive captions. The team wants meaning-based matches even when wording differs or the content is an image caption. What design choice best satisfies this? Select one answer. A. Rely on keyword search across all fields. B. Create a vector index with embeddings using an Azure OpenAI embedding model. C. Translate all non-English content to English and use semantic search only. D. Increase BM25 weights for exact term matches. The correct answer is B. Create a vector index with embeddings using an Azure OpenAI embedding model. Now let's work through why this answer is correct and why the others are not. Option B is correct because embeddings represent content by meaning rather than exact words. This allows the system to match English and Spanish text, paraphrased phrasing, and image captions based on semantic similarity, making it ideal for cross-language and cross-format retrieval. Option A is incorrect because keyword search depends on exact or near-exact terms, which fails when wording changes. Languages differ, or concepts are described differently in image captions. Option C is incorrect because translating everything to English adds complexity, processing overhead, and still does not provide the same robustness for semantic similarity as a vector index built on embeddings. Option D is incorrect because increasing BM25 weights improves exact term matching, but it does not capture meaning. Synonyms, or conceptual similarity across languages or visual descriptions. Question 11. You're designing a flow that enriches text with external data and then summarizes it. The design should be modular and reusable. Which two choices best align with these goals? Select two answers. A. Use a Python tool node to call an external API and return structured data to downstream nodes. B. Chain nodes so the LLM tool consumes either the flow inputs or an upstream node's output. C. Embed the API call directly into a giant prompt so there's only one node. D. Avoid defining node outputs to reduce wiring between components. The correct answers are A. Use a Python tool node to call an external API and return structured data to downstream nodes. And B, chain nodes so the LLM tool consumes either the flow inputs or an upstream node's output. Now let's work through why these answers are correct, and why the others are not. Option A is correct because a Python tool node cleanly separates the external data retrieval step from the rest of the workflow. It returns structured output, which downstream nodes can reuse, test, and replace without rewriting the summarization logic. Option B is correct because chaining nodes creates a modular pipeline, where one node enriches the content and a later node summarizes it. This makes the flow easier to maintain, easier to reuse for similar scenarios, and simpler to extend with additional steps like validation or formatting. Option C is incorrect because embedding the API call into one large prompt collapses multiple responsibilities into a single step, which reduces modularity, makes debugging harder, and limits reuse of the enrichment logic across other flows. Option D is incorrect because defining node outputs is what enables clear interfaces between components. Skipping outputs may reduce visible wiring, but it also reduces clarity, reuse, and reliability when composing flows from reusable parts. Question 12. Which statement best describes runtimes in prompt flow? Select one answer. A runtime is just an endpoint that triggers the flow. B, a runtime combines a compute instance and an environment to run flows. C, a runtime is only a YAML file listing dependencies. D, a runtime is a dataset used for evaluation. The correct answer is B. A runtime combines a compute instance and an environment to run flows. Now let's work through why that is and why the others don't fit. A runtime is correctly described by option B because it brings together the execution resources, such as compute and the software environment, including required packages and libraries, so that flows can run consistently and reliably. In contrast, option A is incorrect because an endpoint is used to expose or trigger a flow, not to define where and how it runs. Option C is incorrect because a YAML file may describe dependencies, but by itself it does not provide compute or execute flows. Option D is incorrect because datasets are used for testing or evaluation, not for executing prompt flows. Question 13. Your company is planning a generative AI feature. Leadership asks who needs to adopt the responsible approach described beyond just the model engineers. What is the most accurate response? Select one answer. A, only the data scientists are responsible for adopting it. B, only the developers implementing the API calls are responsible. C, data scientists, developers, and other contributors involved in creating the generative AI solution should adopt it. D, only compliance and legal teams should adopt it after deployment. The correct answer is C. Data scientists, developers, and other contributors involved in creating the generative AI solution should adopt it. Now let's work through why that is and why the others don't fit. Option C is correct because responsible generative AI practices apply across the entire lifecycle and across roles. Everyone involved in designing, building, testing, and deploying the solution has responsibility for adopting these principles. Option A is incorrect because responsibility is not limited to data scientists, design decisions, implementation choices, and deployment controls also affect responsible outcomes. Option B is incorrect because developers implementing API calls are only one part of the process. Broader contributors influence data handling, prompts, evaluation, and user experience. Option D is incorrect because responsibility is not deferred until after deployment, and it is not limited to compliance or legal teams. Responsible practices must be applied throughout the build and release process. Question 14. For each main agent responsibility, drag it to the correct description. Each item may be used once, more than once, or not at all. Determines which connected agent should handle a task. Selecting the appropriate connected agent. Forwards task-specific instructions and context. Forwarding relevant context and instructions. Aggregates or summarizes results from connected agents. Aggregating or summarizing results. Understands the intent behind user input. Interpreting user input. Unused items. Debugging connected agents. Designing sub-agent prompts. Now let's work through why those matches are correct and why the unused items don't fit. Selecting the appropriate connected agent is correct because the main agent's role includes routing. Choosing the best sub-agent for the task based on what the user is asking for. Forwarding relevant context and instructions is correct because once a sub-agent is selected, the main agent passes along the necessary task details, constraints, and supporting context so the sub-agent can do the job effectively. Aggregating or summarizing results is correct because multiple connected agents may return outputs. And the main agent compiles, reconciles, and summarizes them into one final response for the user. Interpreting user input is correct because the main agent must understand the user's intent first, so it can route the request correctly and decide what context is needed. In contrast, debugging connected agents is not a runtime responsibility of the main agent. It is a design time activity done while building or troubleshooting the system. Finally, designing sub-agent prompts is also not handled dynamically by the main agent at runtime. Those prompts are created when configuring the connected agents, not during request routing and aggregation. Question 15. For each statement below, indicate whether the answer is true or false. You add MCP server info to the agent thread when invoking a prompt so the agent knows which remote servers to use. True. Allowed tools lets you restrict which tools are callable from a particular MCP server. True. If approval is required, the run status becomes requires action, which includes the tool and arguments for review. True. Using the Azure MCP tool requires creating a manual MCP client session and wrapping function tools. False. Now let's work through why each answer is correct. The first statement is true because MCP server information is provided at the thread level. This gives the agent the necessary context at prompt time to know which remote MCP servers it can interact with. The second statement is true because allowed tools acts as an allow list, tightly controlling which tools on an MCP server the agent is permitted to call, improving safety and predictability. The third statement is true because when approval is required, the run enters a requires action state, exposing the proposed tool call and arguments so a developer can review and approve the action. The final statement is false because the Azure MCP tool abstracts MCP connectivity and invocation. It automatically manages the client session and tool wiring, so developers do not need to manually create MCP clients or wrap function tools. Question 16. Fill in the blanks by selecting the correct options from the drop-down menus. The Microsoft Agent Framework supports multimodal interactions, allowing agents to process text, images, and structured outputs, while maintaining type-safe responses. Now let's work through why these selections are correct. The first blank is multimodal interactions. Not because the framework is designed to handle more than one form of input and output, enabling agents to work with different data modalities instead of only plain text. The second blank is text, images, and structured outputs, because these are the explicitly supported content types, allowing agents to reason over text, analyze images, and return structured data suitable for downstream systems. The final blank is type-safe responses, because the framework validates outputs against expected schemas and data types, ensuring responses remain predictable, reliable, and easy to integrate into applications. By contrast, options like audio-only responses, limited text-based output, unstructured messages, or unsecured connections do not describe the supported interaction model or the response guarantees provided by the Microsoft Agent Framework. Question 17. For each statement below, indicate whether it is true or false. Concurrent orchestration can dynamically select which agents to run depending on the task. True. Every workflow must include all registered agents regardless of task requirements. False. Aggregated messages from concurrent workflows include both author name and message content. True. Agents within concurrent orchestration must depend on one another's shared state to complete tasks. False. Now let's work through why each answer is correct. The first statement is true because concurrent orchestration can choose which agents to execute based on what the task needs. So only relevant agents are invoked for that specific request. The second statement is false because including all registered agents is not required. Workflows can run a subset of agents, and running every agent is optional rather than mandatory. The third statement is true because aggregated outputs typically include both the agent identifier, such as the author name, and the message content, so the combined result remains clear and traceable. The final statement is false because agents in concurrent orchestration are designed to work independently. They do not need to rely on shared state between agents to complete their tasks. Question 18. Fill in the blanks by selecting the correct options from the drop-down menus. An agent executor uses a request context to understand incoming task details, and an event queue to send results or updates back to clients. Now let's work through why these selections are correct. Agent executor is correct because it is the runtime component that actually processes the incoming request, runs the needed logic, and produces the response for the user. Request context is correct because it carries the request details, such as the user input, relevant context, and other metadata the executor needs to handle the task appropriately. Event queue is correct because it provides the mechanism to stream, message, or publish results and updates back to the client. Especially when responses are delivered incrementally or asynchronously. In contrast, agent skill is incorrect because it defines what an agent can do, not the component that executes incoming requests. Agent card is incorrect because it describes metadata and configuration, not runtime processing. And router is incorrect because it coordinates where messages go. But it does not perform the actual task execution handled by the agent executor. Question 19. A developer wants to integrate a weather API into an agent to ensure the agent understands available endpoints, parameters, and expected responses. The developer provides a JSON file describing the API's paths, query parameters, and responses. Which integration option is being used? Select one answer. A. Azure function triggered by a storage queue. B. OpenAPI 3.0 tool with a specification file. C. Function calling with an in-process Python function. D. Custom script executed outside the agent runtime. The correct answer is B. OpenAPI 3.0 tool with a specification file. Now let's work through why that is and why the others don't fit. OpenAPI 3.0 tool with a specification file is correct because OpenAPI uses a structured JSON or YAML document to formally describe API endpoints, request parameters, and response schemas. This allows the agent to understand how to call the weather API correctly and what data to expect in return. In contrast, Azure functions triggered by a storage queue are used for event-driven processing, not for describing API contracts to an agent. Function calling with an in-process Python function is also incorrect because it defines executable logic, not a standardized API description with paths and schemas. Finally, a custom script executed outside the agent runtime is incorrect because it is not a supported integration approach for exposing structured API definitions to an agent. And it does not provide the declarative interface the agent needs to reason about endpoints and parameters. Question 20. A product support team struggles to respond quickly to a constant stream of bug reports and feature requests. The team needs a solution that reduces manual review time while maintaining accuracy and avoiding hard-coded workflows. Which approach best these requirements? Select one answer. A. Use connected agents where specialized subagents classify tickets, assign priority, and suggest routing, coordinated by a main agent. B. Develop a larger monolithic agent to handle classification, prioritization, and routing within one process. C. Hire additional staff to manually process tickets for faster turnaround. D. Implement a static script with hard-coded logic to route tickets based on keywords. The correct answer is A. Use connected agents where specialized subagents classify tickets, assign priority, and suggest routing, coordinated by a main agent. Now let's work through why that is and why the others don't fit. Option A is correct because connected agents split the workload into specialized roles. One subagent can focus on classification, another on priority scoring, and another on routing recommendations, while the main agent coordinates and aggregates results. This reduces manual review, improves consistency, and avoids brittle keyword-based workflows. In contrast, option B is incorrect because expanding one monolithic agent increases complexity, makes changes harder, and reduces maintainability compared to modular specialized agents. Option C is incorrect because hiring more staff increases manual effort rather than reducing it, and it does not provide the automation and consistency the scenario requires. Finally, option D is incorrect because hard-coded keyword routing is inflexible, breaks when wording varies, and directly conflicts with the requirement to avoid static workflows. Question 21. Arrange the steps to set up and run a multi-agent solution in the correct order. Instruction. Drag and drop the items into the correct order, starting with the first step at the top. Initialize the agent's client. Create a connected agent definition. Initialize the connected agent tool. Create the main agent and assign tools. Create a thread and send a message. Run the agent workflow. Handle the results. Now that we have gone through question 21 in the correct order, let me explain how this sequence works in practice. First, you initialize the agent's client because this establishes the core connection and configuration needed to manage agents and communication. Without this foundation, no agents can be created or executed. Next, you create a connected agent definition, which describes the subagents, their roles, and how they can be invoked. This step defines the building blocks of the multi-agent system. After that, you initialize the connected agent tool, linking the agent definition to the runtime so those connected agents can actually be called during execution. Then, you create the main agent and assign tools, including the connected agent tool. This is where the orchestration logic lives, allowing the main agent to coordinate subagents effectively. Once the agents are set up, you create a thread and send a message, which starts the interaction by providing user input or task instructions. Following this, you run the agent workflow, allowing the system to orchestrate tasks, invoke connected agents, and process the request end-to-end. Finally, you handle the results, collecting outputs, aggregating responses, and delivering the final result back to the user or calling application. Question 22. Arrange the following SDK methods called by the chat manager during each round of conversation in the correct order. Instruction: drag and drop the items into the correct order, starting with the first step at the top. Should request user input. Should terminate. Filter results. Select next agent. Now let's work through why this order is correct. Should request user input comes first, because the chat manager must decide whether it needs more information from the user before it can proceed. If additional input is required, the flow pauses to request it rather than continuing prematurely. Next, should terminate runs to determine whether the conversation should end, based on completion criteria or the current context. If the session is finished, there is no reason to continue processing or selecting another agent. Then, filter results is applied to refine outputs, improving relevance and quality by removing noise or adjusting what will be carried forward into the next step. Finally, select next agent occurs because once the system knows it can continue and the results are filtered. If the chat manager chooses which agent should handle the next turn to keep the conversation moving logically. Question 23. How does the A2A framework ensure that a request reaches the correct agent in a multi-agent system? Select one answer. A. By sending requests randomly until an agent responds. B. Through a routing agent that delegates requests based on agent capabilities. C. By requiring all agents to share a common codebase. D. Through manual configuration of request paths. The correct answer is B, through a routing agent that delegates requests based on agent capabilities. Now let's work through why that is and why the others don't fit. The correct answer is option B, because the A2A framework uses a routing agent that examines agent capabilities, typically defined in agent metadata, and then delegates each request to the most appropriate agent. This ensures accurate, efficient, and scalable request handling in a multi-agent system. In contrast, option A is incorrect because random request dispatch would be inefficient and unreliable. And A2A is specifically designed to avoid randomness through structured routing. Option C is incorrect because agents do not need to share a common codebase. They can be independently implemented, with A2A handling communication and coordination between them. Option D is incorrect because manual configuration of request paths defeats the purpose of A2A, which automates routing decisions to reduce maintenance effort and improve flexibility. Question 24. What is the role of the base chat client abstraction within the Microsoft Agent Framework? Select one answer. A. Provides a unified interface for connecting to multiple AI service providers. B. Handles the storage of conversation history across sessions. C. Generates type-safe responses for structured outputs. D. Manages security authentication through Azure CLI credentials. The correct answer is A. Provides a unified interface for connecting to multiple AI service providers. Now let's work through why that is and why the others don't fit. Option A is correct because the base chat client abstraction standardizes how agents interact with different AI providers. It allows the framework to switch between services such as Azure OpenAI, or other supported providers without changing the higher-level agent logic. In contrast, option B is incorrect because conversation history is handled by agent threads, not by the base chat client itself. Option C is incorrect because type-safe responses relate to structured output validation and schema enforcement, which are handled elsewhere in the framework, not by the chat client abstraction. Finally, option D is incorrect because authentication is managed through external mechanisms, such as Azure CLI or identity libraries, rather than being a responsibility of the base chat client. Question 25. Which three items are recommended best practices when creating custom function tools? Select three answers. A. Clear, detailed descriptions for functions and parameters. B. Combine many unrelated responsibilities into one function. C. Omit error handling to keep functions short. D. Proper Python type annotations for inputs and outputs. E. Return meaningful data the AI can use. The correct answers are A. Clear, detailed descriptions for functions and parameters. D. Proper Python type annotations for inputs and outputs. And E. Return meaningful data the AI can use. Now let's work through why these choices are correct and why the others don't fit. Clear, detailed descriptions for functions and parameters are correct because the AI depends on these descriptions to understand when a function should be called, what each parameter represents, and how the function should be used. This reduces incorrect calls and improves reliability. Proper Python type annotations for inputs and outputs are correct because type hints clearly define expected data structures, enabling type-safe interactions, better validation, and more predictable behavior when the AI reasons about function usage. Return meaningful data the AI can use is correct because the function's output directly influences the AI's next step. Structured and useful return values help the AI generate accurate responses or make informed decisions. In contrast, combining many unrelated responsibilities into one function is incorrect because it reduces clarity, hurts modularity, and makes functions harder to reuse and maintain. Similarly, omitting error handling is incorrect because robust error handling is essential for dealing with unexpected inputs or failures, and for building stable and reliable AI-powered systems. Question 26. Which of the following accurately describes how agents interact within the Microsoft Agent Framework? Select one answer. A. They can interact with APIs but not with human users. B. They rely solely on local scripts with no API communication. C. They communicate only with other agents and not with external systems. D. They interact with users, APIs, and external services through defined workflows. The correct answer is D. They interact with users, APIs, and external services through defined workflows. Now let's work through why that is and why the others don't fit. Option D is correct because agents in the Microsoft Agent Framework are designed to operate across multiple interaction surfaces. They can respond to users, call APIs, and integrate with external systems, all coordinated through structured workflows that manage execution and orchestration. In contrast, option A is incorrect because agents are not limited to API interactions. They are explicitly designed to interact with human users as well. Option B is incorrect because agents are not restricted to local scripts. The framework supports rich API and service-based integrations. Option C is incorrect because agents are not isolated to agent communication. They are intended to work with external systems and services as part of real-world solutions. Question 27. You are designing an A2A server to connect your AI agent to multiple client applications. The agent must handle simultaneous tasks, stream results, and be discoverable by other agents. Which combination of components ensures this setup functions correctly? Select two answers. Agent card. B. Data pipeline. C. Server application. D. Request handler. E. Cloud scheduler. The correct answers are A. Agent card, and D. Request handler. Now let's work through why these are correct and why the others don't fit. Agent card is correct because it exposes the agent's capabilities, skills, and communication details. This is what allows other agents and external clients to discover the agent and understand how to interact with it. Request handler is also correct because it processes incoming requests, manages concurrent task execution, and supports streaming results and updates back to clients, which is essential for handling simultaneous workloads reliably. In contrast, server application on its own is incorrect because while it hosts the agent, it does not provide discoverability or structured request handling without the agent card and request handler. Data pipeline is incorrect because it relates to data processing workflows, not agent discovery or request orchestration in an A2A setup. Finally, Cloud Scheduler is incorrect because it handles time-based job execution, not real-time request handling, streaming, or agent discovery. Question 28. Fill in the blanks by selecting the correct options from the drop-down menus. Entity linking resolves ambiguous names in text by connecting them to specific Wikipedia articles based on context. Each linked entity includes identifiers such as Bing ID and URL, which provide unique reference and location details. Now that we have gone through question 28 and the completed statement, let me explain why each selection is correct. Ambiguous names is correct because entity linking is designed to handle terms that can refer to multiple things, such as a word that might represent a person, a place, or a concept depending on usage. Wikipedia is correct because it serves as the external knowledge base, providing authoritative articles that entities can be linked to for clear identification. Context is correct because surrounding words and meaning determine which specific article is the best match, ensuring the entity is resolved accurately rather than arbitrarily. Bing ID and URL are correct because they act as unique identifiers, allowing systems to consistently reference the exact entity and locate its canonical information source without confusion. Together, these elements explain how entity linking disambiguates names, anchors them to real-world knowledge, and provides precise references for downstream processing. Question 29. For each statement below, indicate whether it is true or false. Azure AI language question answering can be accessed through a REST endpoint. True, the knowledge base must always be created manually by typing in question and answer pairs. False. Built-in chit-chat pairs can help handle casual user interactions. True. The question answering feature replaces Azure Bot Service. False. Now let's work through why each answer is correct. The first statement is true because Azure AI language question answering exposes a REST API, allowing applications such as bots or web apps to send questions and receive answers programmatically. The second statement is false because knowledge bases do not have to be created manually. They can be automatically generated from FAQs, documents, or structured files, which significantly reduces setup effort. The third statement is true because built-in chit-chat pairs are designed to handle everyday conversational inputs, such as greetings or small talk, improving the natural feel of user interactions. The final statement is false because question answering does not replace Azure Bot Service. Instead, it complements it, with bots often using question answering as one component within a broader conversational solution. Question 30. For each data source type, drag the correct description into the correct match column. Each item may be used once, more than once, or not at all. URLs containing web-based FAQ content, web page URLs, files with structured text used to generate questions and answers, structured text files, predefined chit-chat datasets for conversational tone, chit-chat datasets, unused items, audio recordings, PDF images. Now let's work through why these matches are correct and why the unused items don't fit. Web page URLs are correct because they allow the system to automatically extract question and answer pairs from online FAQ pages. This makes it easy to keep a knowledge base aligned with existing web content. Structured text files are correct because formatted documents such as guides or manuals contain clearly organized text, from which questions and answers can be reliably generated. Chit-chat datasets are correct because they provide predefined conversational responses, helping bots handle greetings, small talk, and casual interactions in a more natural and friendly way. In contrast, audio recordings are not suitable as a direct data source because they must first be transcribed into text before questions and answers can be derived. Similarly, PDF images are not usable on their own because image-based PDFs require OCR or text extraction before they can contribute meaningful content to a knowledge base. Question 31. Fill in the blanks by selecting the correct options from the drop-down menus. To create a question-answering knowledge base, you must enable the question answering feature and create or select an Azure AI search resource to host the index before adding data sources. Now let's work through why these selections are correct. Enable the question answering feature is correct because the question answering capability must be turned on within the Azure AI language resource. Without enabling it, the service cannot create or manage a question answering knowledge base. Create or select an Azure AI search resource is correct because the knowledge base relies on Azure AI search to store, index, and retrieve question and answer content efficiently. This search index is a required foundation before any data can be ingested. Adding data sources comes last because only after the feature is enabled and the search index exists can documents, URLs, or files be added to populate the knowledge base with usable question and answer pairs. This sequence ensures the service is properly configured, the storage layer is ready, and the knowledge base can be built without setup or indexing errors. Question 32. For each VoiceLive API component or configuration concept, drag it to the appropriate description in the correct match column. Each item may be used once, more than once, or not at all. Manages session configuration and behavior, session.update, used to append audio bytes to the input buffer, input audio buffer.append, indicates the completion of a generated response. Response.done, enables connection setup for WebRTC-based avatars, session.avatar.connect. Now, let's work through why each match is correct. Session.update is correct because it is responsible for controlling and modifying the session configuration. This includes adjusting modalities, voice settings, and other behavioral parameters dynamically during a live session. Input audio buffer.append is correct because it is used to stream audio data into the system. Appending audio bytes allows real-time processing, such as transcription or live model inference. Response.done is correct because it signals that the model has finished generating its response. This event lets the client know that no further output is expected for that request. Session.avatar.connect is correct because it establishes the WebRTC connection, enabling real-time streaming between the client and an avatar for voice or visual interaction. By contrast, response.create is not used for session configuration. It simply triggers model inference, and conversation.item created only notifies that a new conversation item exists. Without configuring sessions or handling audio or avatar connections. Question 33. For each statement below, indicate whether the answer is true or false. Azure AI Language provides pre-built classification features such as sentiment and language detection. True. Custom text classification lets developers define their own categories beyond pre-built ones. True. SDKs are required to use the Azure AI Language Service. False. Setting multilingual to true forces all documents to be translated automatically. False. Now let's work through why each answer is correct. The first statement is true because Azure AI Language includes built-in models for sentiment analysis, language detection, and other common text classification tasks. The second statement is true because custom text classification allows developers to create their own labels, enabling domain-specific categorization beyond the standard pre-built options. The third statement is false because SDKs are optional. All Azure AI language capabilities can also be accessed directly through REST APIs without using an SDK. The final statement is false because the multilingual setting only enables support for multiple languages. It does not perform automatic translation of the content. Question 34. A developer wants to ensure their application produces speech that matches the target device's required sampling rate and bit depth. They use the method set speech synthesis output format to define these parameters. Select one answer. A. The method allows setting the input text language. B. The method controls the output format of synthesized audio. C. The method adjusts microphone input volume automatically. D. The method determines which neural model is used for speech generation. The correct answer is B. The method controls the output format of synthesized audio. Now let's work through why that is and why the others don't fit. Option B is correct because set speech synthesis output format defines the characteristics of the generated audio, such as file type, sample rate, and bit depth, ensuring compatibility with the target playback device. In contrast, option A is incorrect because language selection is handled by voice or language configuration, not by the audio output format method. Option C is incorrect because the method affects synthesized audio output, not microphone input volume or recording behavior. Option D is incorrect because neural voice or model selection is controlled through voice settings, not through the output format configuration method. Question 35. A developer has constructed an SSML string that switches voices and includes phoneme and break directives. They now need to generate the audio from this SSML using the client library. Select one answer. A. Pass the SSML to a method that accepts SSML input on the speech synthesizer. B. Convert the SSML to plain text and call the text-to-speech method. C. Load the SSML into a speech recognition grammar and run recognition. D. Attach the SSML to the microphone input stream. The correct answer is A. Pass the SSML to a method that accepts SSML input on the speech synthesizer. Now let's go through the explanation. Option A is correct because the speech synthesizer provides a dedicated method designed to accept SSML directly. This allows the engine to interpret voice switches, phonemes, pauses, and other SSML directives exactly as authored, producing audio that matches the intended pronunciation and prosody. By contrast, option B is incorrect because converting SSML to plain text strips out all SSML controls, such as breaks and phonemes, resulting in a loss of speech customization. Option C is incorrect because speech recognition grammars are used for speech-to-text scenarios, not for generating synthesized audio from markup. Option D is incorrect because microphone input streams are intended for capturing live audio, not for supplying SSML markup to a speech synthesis engine. Question 36. For each statement below, indicate whether it is true or false. Speech translation first transcribes speech before translating it. True. Azure AI Speech uses AI and machine learning to perform translations. True. Each translation resource must be created separately for every target language. False. Keys and endpoint details can be viewed in the Azure portal. True. Now let's go through the explanation. To begin with, the first statement is true because speech translation works in stages. It first recognizes spoken audio and converts it into text, and then translates that text into the target language. Next, the second statement is also true because Azure AI Speech relies on artificial intelligence and machine learning models, enabling accurate and scalable multilingual translation. However, the third statement is false because a single Azure AI speech translation resource can support multiple target languages. There is no need to create a separate resource for each language. Finally, the fourth statement is true because the Azure portal provides a dedicated keys and endpoint section, where developers can view and manage authentication keys and regional endpoint information. Question 37. Arrange the following steps to configure and initiate a VoiceLive API session in the correct sequence. Instruction. Drag and drop the items into the correct order, starting with the first step at the top. Establish a WebSocket connection to the VoiceLive API endpoint. Authenticate using Microsoft Entra token or API key. Send a session.update event to configure session parameters. Append and commit audio to the input buffer for processing. Receive response.done event when processing completes. Now let's work through why this order is correct. First, you establish a WebSocket connection to the VoiceLive API endpoint, because real-time audio exchange requires an open, persistent connection for streaming events and data. Next, you authenticate using a Microsoft Entra token or an API key, because the service must validate identity and authorize access before it will accept configuration events or audio input. Then, you send a session.update event because this is where you define how the session should behave, including modalities, voice settings, and audio formats needed for processing. After that, you append and commit audio to the input buffer, because once the session is configured, the system can accept streamed audio bytes and process them for recognition, translation, or response generation. Finally, you receive the response.done event, because this event indicates the server has completed generating the response, signaling that processing for that request cycle is finished. Question 38. What distinguishes the responses produced by Azure AI language question answering and language understanding? Select one answer. A. Both require the client application to generate all responses manually. B. Language understanding provides predefined answers stored in a knowledge base. C. Question answering produces static answers. Language understanding identifies intent and entities. D. Both produce static answers. The correct answer is C. Question answering produces static answers. Language understanding identifies intent and entities. Now let's work through why that is and why the others don't fit. Option C is correct because Azure AI language question answering works by matching a user's question to predefined answers stored in a knowledge base. The response is static and retrieved, not inferred. Language understanding, on the other hand, does not return answers directly. Instead, it analyzes the user's utterance to identify intent, extract entities, and provide structured signals that the application uses to decide what action or response should follow. In contrast, option A is incorrect because question answering automatically returns answers without requiring the client to manually generate them. Option B is incorrect because predefined answers stored in a knowledge base are a feature of question answering, not language understanding. Finally, option D is incorrect because only question answering produces static answers. Language understanding focuses on interpretation, not direct response generation. Question 39. An engineer wants to quickly find mentions of cities and dates in large text files without creating a custom model. Select one answer. Select one answer. A. Custom named entity recognition. B. Built-in named entity recognition. C. Custom text classification. D. Language understanding. The correct answer is B. Built-in named entity recognition. Now let's work through why that is and why the others don't fit. Option B is correct because built-in named entity recognition is designed to automatically detect common entity types, such as locations, dates, times, and organizations, with no need for training or custom configuration. This makes it ideal for quickly extracting cities and dates from large volumes of text. In contrast, option A is incorrect because custom named entity recognition requires defining custom entity labels and training a model, which is unnecessary for standard entities like cities and dates. Option C is incorrect because custom text classification is used to categorize entire documents or text segments, not to extract specific entities within the text. Finally, option D is incorrect because language understanding focuses on identifying user intent and entities within conversational input, rather than scanning large text files for entity extraction. Question 40. In a custom NER labeling project, what is the purpose of the multilingual property in the JSON metadata? Select one answer. A allows labeling and training with documents in multiple languages. B determines how long each labeled region can be. C defines the dataset name used for each labeled document. D specifies whether multiple annotators can label simultaneously. The correct answer is A. Allows labeling and training with documents in multiple languages. Now let's work through why that is and why the others don't fit. Option A is correct because setting the multilingual property to true enables a single custom NER project to include documents written in different languages. This allows the model to be trained across multiple languages within one unified labeling and training workflow. In contrast, option B is incorrect because the length of labeled regions is controlled by character offsets and spans in the annotations, not by the multilingual setting. Option C is incorrect because dataset naming is handled through dataset definitions in the project configuration, not by the multilingual metadata flag. Finally, option D is incorrect because annotation concurrency, meaning whether multiple annotators can label at the same time, is managed by project collaboration features, not by the multilingual property. Question 41. A platform team wants a single Azure resource that will support speech features today and make it easy to add other AI capabilities later, without creating separate resources for each capability. They also want to keep management simple. Select two answers. A. Azure AI Services. B. Dedicated Azure AI Speech Resource. C. Azure AI Foundry. D. Azure Kubernetes Service. E. Azure Policy. The correct answer is A. Azure AI Services. And C. Azure AI Foundry. Now let's work through why these fit the requirement and why the others do not. Azure AI Services is correct because it is a multi-service resource. It allows speech to run alongside other AI capabilities such as vision or language, all under a single endpoint and key. This significantly reduces resource sprawl and simplifies management as new capabilities are added. Azure AI Foundry is also correct because it provides a centralized, multi-service environment designed to host and manage multiple AI services together, making it easy to expand beyond speech while keeping administration streamlined. In contrast, a dedicated Azure AI speech resource is incorrect because it supports only speech. Adding other AI services would require provisioning and managing additional resources. Azure Kubernetes Service is incorrect because it is a compute and orchestration platform, not an AI service resource, providing speech or other AI APIs. Finally, Azure Policy is incorrect because it is a governance and compliance tool. It does not provide AI capabilities or speech functionality. Question 42. What is the purpose of the XML lang attribute in an SSML speak element? Select one answer. A. It identifies which speech synthesis engine is used. B. It controls the sample rate of the synthesized audio. C. It defines the style or tone of the neural voice. D. It sets the language of the SSML document so that pronunciation rules follow that locale. The correct answer is D. It sets the language of the SSML document so that pronunciation rules follow that locale. Now let's work through why that is and why the others don't fit. Option D is correct because the XML lang attribute specifies the base language for the SSML content. This ensures the speech engine applies the correct phonetic and pronunciation rules for that language, producing natural and accurate speech output. In contrast, option A is incorrect because the speech synthesis engine is selected automatically by the service, not by the XML lang attribute. Option B is incorrect because sample rate and audio format are controlled through audio output configuration settings, not through SSML language attributes. Finally, option C is incorrect because voice style or expressive tone is defined using SSML style or prosody elements, not by the XML lang attribute. Question 43. Which property in a language detection request body identifies the analysis operation being performed? Select one answer. A. Kind. B. Category. C. Task type. D. Detector. The correct answer is A. Kind. Now let's work through why that is and why the others don't fit. Option A is correct because the kind property explicitly specifies the type of analysis task being requested, such as language detection. This tells the Azure AI language service exactly which operation to execute on the submitted text. In contrast, option B is incorrect because category is not a valid property in the language detection request schema. Option C is incorrect because task type is not used by this API to define the analysis operation. Finally, option D is incorrect because detector is not a recognized parameter in the request body. The service relies on the kind property to determine the analysis being performed. Question 44. Which training configuration should be used when a dataset is small and must preserve balanced representation of all labels? Select one answer. A. Manual split. B. Automatic split. C. Randomized training. D. Incremental split. The correct answer is A. Manual split. Now let's work through why that is and why the others don't fit. Option A is correct because a manual split allows the developer to deliberately control how data is divided between training and testing sets. This is especially important for small data sets, where automatic splitting could easily result in some labels being underrepresented or missing entirely. In contrast, option B is incorrect because automatic split works best with large, well-balanced data sets and offers less control over label distribution. Option C is incorrect because randomized training is not a defined or supported training configuration in Azure AI language. Finally, option D is incorrect because incremental split is not an available option for configuring dataset splits in this context. Question 45. When sending prompts that include both text and audio to a multimodal model, which format is used to represent the message structure? Select one answer. A. CSV. B. HTML. C. JSON. D. YAML. The correct answer is C. JSON. Now let's work through why that is and why the others don't fit. Option C is correct because multimodal prompts are structured using JSON. JSON allows the request to clearly define roles, content types, and data payloads, such as text segments and audio inputs, in a single structured message that the model can reliably parse. In contrast, option A is incorrect because CSV is designed for flat, tabular data and cannot represent hierarchical message structures or multiple content types. Option B is incorrect because HTML is used for web page markup and presentation, not for encoding structured prompt data for model inference. Finally, option D is incorrect because although YAML is used for configuration files, it is not used to represent runtime prompt messages sent to multimodal model endpoints. Question 46. For each Azure AI Vision visual feature, drag it to the appropriate box in the correct match column to align it with its immutable definition. Generates more detailed captions for objects detected, visual features.dense captions. Returns the bounding box of the specified aspect ratio for the area of interest. Visual features.smart crops. Extracts readable text. Visual features.read. Now let's work through why each match is correct and why the unused items don't fit. Visual features dense captions is correct because it produces fine-grained natural language descriptions tied to specific detected regions in an image, going beyond a single global caption to describe multiple objects and details. Visual features.smart crops is correct because it calculates crop regions based on a specified aspect ratio, ensuring the most important part of the image remains in focus for thumbnails or resized displays. Visual features.read is correct because it performs optical character recognition, extracting readable printed or handwritten text from images and returning it in a machine-readable format. In contrast, visual features.audio transcription is not applicable because audio transcription is outside the scope of image analysis and is not an Azure AI Vision visual feature. That is how these Azure AI Vision visual features align with their correct definitions. Question 47. Fill in the blanks by selecting the correct options from the drop-down menus. When using the Azure AI Vision Face API, you can call the detect method through either the REST interface or a language-specific SDK. Both methods return the same structured face data that includes rectangles, attributes, and values for each detected face. Now that we have gone through the full sentence and the completed answers, let me explain why these options are correct. First, the REST interface is correct because it allows direct HTTP calls to the Face API, making it accessible from any platform that can send REST requests. Next, a language-specific SDK is also correct because SDKs provide convenient wrappers around the same REST endpoints, simplifying integration for developers using languages like Python, C#, or Java. Finally, structured face data is the correct output because regardless of whether you use REST or an SDK, the detect method returns consistent, well-defined face information, including bounding rectangles and analyzed facial attributes. This consistency ensures developers can switch between access methods without changing how they process the results. Question 48. A company wants to deploy its image classification model in multiple regions for performance and reliability while keeping training centralized. Select one answer. A. Create one combined resource for both training and prediction in each region. B. Use one training resource for model development and multiple prediction resources in different regions. C. Use separate training resources for each application to avoid duplication. D. Train models directly in the prediction resources to reduce latency. The correct answer is B. Use one training resource for model development and multiple prediction resources in different regions. Now let's work through why that is and why the others don't fit. Option B is correct because it keeps training centralized in a single training resource, which supports consistent datasets and model development. Meanwhile, multiple prediction resources can be deployed across regions, improving latency and reliability by serving inference closer to users. In contrast, option A is incorrect because training and prediction are separate resource types, And creating combined resources per region increases complexity without providing the intended centralized training model. Option C is incorrect, because using separate training resources for each application duplicates effort unnecessarily and makes it harder to keep training consistent and centrally managed. Finally, option D is incorrect because prediction resources are designed for inference only. Training is not performed inside prediction resources, so this approach does not match how custom vision is structured. Question 49. Fill in the blanks by selecting the correct options from the drop-down menus. A typical workflow is to create a classification project, upload images with class label tags, train and evaluate the model, test its behavior, and then publish the trained model to a prediction resource for application use. Now that we've gone through the full sentence and the completed answers, let me explain why these options are correct. Classification project is correct because image classification starts by defining a project type focused on assigning labels to images, which sets up the tagging and training workflow. Class label tags is correct because the model learns by associating each uploaded image with one or more class labels. So tagging is the foundation for supervised training. Train and evaluate is correct because the system must build the model from the labeled images. And then measure performance to confirm the model is learning the intended patterns. Test is correct because you validate how the trained model behaves on sample images, confirming it generalizes correctly before deployment. Publish is correct because publishing makes the trained iteration available for inference, turning it into a callable endpoint version for real usage. Prediction resource is correct because predictions are served from the prediction endpoint, allowing applications to submit new images and receive classification results. Question 50. For each statement below, indicate whether the answer is true or false. The API key should be provided in the authorization header when calling the endpoint. True. DAL E3 supports returning 4 images from one request by setting n 4. False. The response includes a revised prompt that may differ from the original prompt. True. The URL field points to a PNG that can be viewed or downloaded. True. Now that we have gone through all the statements and their answers, let's walk through why each one is marked that way. The first statement is true because API authentication is handled by passing the API key in the authorization header, which is the standard and secure method used by the service. The second statement is false because DALI 3 enforces a single image per request, meaning n must be set to 1. And generating multiple images requires multiple separate requests. The third statement is true because the service may refine or adjust the original prompt, returning this modified version as revised prompt, which reflects how the model interpreted the request. The final statement is true because the response includes a direct URL, typically data 0 URL, that points to a generated PNG image, which can be viewed in a browser or downloaded for use. Question 51. What are valid advantages of pre-built models in Azure AI Document Intelligence? Select 2 answers. A. They automatically translate extracted text into any language. B. They reduce complexity for common document types. C. They accelerate integration into workflows and applications. D. They require extensive manual labeling before first use. The correct answer is B. They reduce complexity for common document types. And C. They accelerate integration into workflows and applications. Now, let's work through why those are the correct choices and why the others are not. Option B is correct because pre-built models are designed to handle common document types such as invoices, receipts, and forms out of the box. This removes the need to design schemas or train custom models, significantly reducing implementation complexity. Option C is also correct because these models come with ready-made outputs and schemas, which allows developers to plug them directly into existing workflows and applications, speeding up development and deployment. In contrast, option A is incorrect because automatic translation is not handled by Azure AI Document Intelligence. Translation is provided by Azure AI Translator, which is a separate service. Finally, option D is incorrect because pre-built models do not require manual labeling before use. Labeling is only necessary when creating custom models tailored to specific document formats. Question 52. You're building an app to read text from product labels photographed in Spanish. You want consistent OCR output without changing the backend service. Select one answer. A. Set the image analysis language option to ES when calling the read feature. B. Use dense captions instead of read to improve language accuracy. C. Call a video analysis endpoint because it handles multilingual input automatically. D. Disable language detection and rely solely on the default English setting. The correct answer is A. Set the image analysis language option to ES when calling the read feature. Now let's work through why that is and why the others don't fit. Option A is correct because the read feature supports specifying a language hint in the client request. By explicitly setting the language to Spanish using S, the OCR engine applies Spanish-specific recognition rules, which results in more consistent and accurate text extraction without requiring any changes to the backend service. In contrast, option B is incorrect because dense captions is designed to generate descriptive captions about image content to extract readable text. It does not perform OCR and therefore cannot improve text recognition accuracy. Option C is incorrect because video analysis endpoints are intended for processing video streams, not still images. Using them adds unnecessary complexity and does not address OCR language consistency. Finally, option D is incorrect because relying on the default English setting can reduce accuracy when processing Spanish text. Disabling language detection does not help. It increases the likelihood of misrecognized characters and words. That is why setting the image analysis language option to ES is the correct and most effective choice in this scenario. Question 53. A secure facility photographs each person entering and exiting. The system must confirm that everyone leaving is the same person who entered without knowing their names. Select one answer. A. Face verification using cached face IDs. B. Face identification using a person group. C. Facial recognition with persisted faces. D. Facial liveness detection. The correct answer is A. Face verification using cached face IDs. Now let's work through why that is and why the others don't fit. Option A is correct because face verification is designed to answer a very specific question. Are these two faces from the same person? It compares a newly detected face against a previously captured and cached face ID, without requiring names, identities, or long-term storage. This makes it ideal for entry and exit scenarios where anonymity must be preserved. In contrast, option B is incorrect because face identification using a person group is meant to determine who a person is. It requires enrolling individuals into a group and associating faces with identities, which goes beyond simply confirming that two appearances belong to the same person. Option C is incorrect because facial recognition with persisted faces focuses on long-term identity management. Persisted faces are stored for repeated recognition over time, not for short-lived verification between two moments. Finally, option D is incorrect because facial liveness detection is used to determine whether a face is real and not spoofed. It does not compare two faces to confirm they belong to the same individual. That is why face verification using cached face IDs is the correct and most appropriate choice for this security requirement. Oh. Question 54. Which statement accurately describes persisted faces in Azure Face API? Select one answer. A. They expire automatically after 24 hours. B. They are stored indefinitely for identified persons in a person group. C. They can only be used for one-time verification. D. They are created automatically whenever a face is detected. The correct answer is B. They are stored indefinitely for identified persons in a person group. Now let's work through why that is and why the others don't fit. Option B is correct because persisted faces are intentionally stored as part of a person group. They remain linked to identified individuals and are reused across identification and verification operations. They do not expire automatically and are designed for long-term recognition scenarios. In contrast, option A is incorrect because automatic expiration after 24 hours applies only to temporary face IDs, not persisted faces stored in a person group. Option C is incorrect because persisted faces are not limited to one-time verification. They can be reused repeatedly for both verification and identification tasks. Finally, option D is incorrect because persisted faces are not created automatically. They are explicitly added during person group setup. Face detection alone does not create persisted faces. That is why persisted faces are best described as being stored indefinitely for identified persons in a person group. Question 55. A company wants to enable employees to find relevant policies and documents across internal websites and applications through a centralized search portal. Select one answer. A. Enterprise Search. B. Data Factory Pipelines. C. Azure Synapse Workspace. D. Cognitive Services Vision API. The correct answer is A. Enterprise Search. Now let's work through why that is and why the others don't fit. Option A is correct because Azure AI Search directly supports enterprise search scenarios. It indexes content from internal websites, document repositories, and applications, and exposes a centralized search experience that allows employees to quickly discover relevant policies and documents. In contrast, option B is incorrect because data factory pipelines are designed for data integration and ETL workflows, not for indexing or querying documents for search purposes. Option C is incorrect because Azure Synapse Workspace focuses on analytics, data warehousing, and big data processing, rather than providing an enterprise-wide document search capability. Finally, option D is incorrect because the Cognitive Services Vision API is used for image analysis, such as OCR or object detection, and does not provide document indexing or search functionality. That is why Enterprise Search is the Azure AI search feature that directly supports this centralized document discovery use case. Question 56. For each REST API concept, drag the appropriate item from the list into the correct match column. Each item may be used once, more than once, or not at all. Identifier returned for an asynchronous analysis task. Operation ID. Header pointing to the endpoint to poll for operation status or results. Operation location. Function used to submit content for analysis. Post analyze. Function used to retrieve analysis status and final JSON output. Get results. Where to obtain the endpoint and keys for authentication. Portal or Foundry. Now let's work through why these matches are correct and why the unused options don't apply. Operation ID is correct because asynchronous REST APIs return an operation identifier that uniquely tracks the submitted analysis job. This ID is required to monitor progress and retrieve results later. Operation location is correct because the service returns a response header containing a URL. This URL is the polling endpoint the client must call to check status or obtain final results. Post-analyze is correct because analysis always begins by submitting content to the service. This operation sends documents or images to the analyzer and starts the asynchronous processing workflow. Get results is correct because clients must repeatedly call this endpoint to check whether processing has completed. Once complete, it returns the final structured JSON output. Portal or Foundry is correct because service endpoints and API keys are obtained from the Azure Portal or Azure AI Foundry. These locations provide authentication details required to call the REST APIs. In contrast, query string key authentication is incorrect because Azure AI services require keys to be sent in request headers, not as URL parameters. Public internet routing is also incorrect because network routing configuration is unrelated to REST API concepts such as operation tracking or result retrieval. That is why these mappings correctly align each REST API concept with its corresponding function or identifier. Question 57. An application analyzing an image document receives a JSON result containing both structured fields and a property called Markdown. What purpose does this property serve? Select one answer. A. It provides a text-based representation of the analyzed content for easier viewing or downstream use. B. It contains the binary encoding of the original document. C. It specifies configuration settings for pagination. D. It identifies which analyzer template was used. The correct answer is A. It provides a text-based representation of the analyzed content for easier viewing or downstream use. Now let's work through why that is and why the others don't fit. Option A is correct because the Markdown property is designed to present the extracted and analyzed document content in a readable text-based format. It complements the structured JSON fields by offering a human-friendly representation, which is useful for display, review, or passing into downstream systems, such attaching as a large language model or rendering in an application. In contrast, option B is incorrect because binary data for the original document is never returned in the analysis response. The service processes the document, but does not embed raw binary content in the JSON output. Option C is incorrect because pagination and page-level details are handled through page or layout-related fields in the response, not through the Markdown property. Finally, option D is incorrect because information about which analyzer or model was used is provided through analyzer identifiers or metadata fields, not through the Markdown content itself. Question 58. Fill in the blanks by selecting the correct options from the drop-down menus. To call the service from code, you must authenticate using a service endpoint and an API key. And it is recommended to submit documents using asynchronous calls, so the application can wait for completion without blocking. The correct answer is service endpoint, API key, and asynchronous. Now let's work through why that is and why the others don't fit. Service endpoint is correct because the endpoint is the URL that tells your code exactly where the Azure AI service is hosted. Without the correct endpoint, your request cannot reach the right resource. API key is also correct because it authorizes the call. The key proves your application has permission to use that endpoint. And it must be included with each request for authentication. Asynchronous is correct because document analysis can take time. Submitting work asynchronously allows your app to continue running other tasks, then check back for results when processing is complete, instead of freezing the application while it waits. In contrast, options like connection string, client certificate, or SSH key are incorrect because they are not the standard authentication mechanism used for this service in this context. The expected pattern is endpoint plus API key. Likewise, synchronous is incorrect because it forces the application to block until processing finishes, which is not recommended when analysis may take several seconds or longer. Question 59. For each statement below, indicate whether the answer is true or false. Statement 1. The pages parameter can restrict processing to a specific range in multi-page PDF or TIFF when using the read model. True. Statement 2. Merged cells prevent the layout model from extracting a table. False. Statement 3. Entities must be present for the model to return any key value pairs. False. Statement 4. The layout model can return row and column indexes for cells even when a table lacks header rows. True. Now let's work through why that is and why the others don't fit. Starting with the first statement, this is true because the read model supports page range selection. By using the pages parameter, you can limit analysis to specific pages in a multi-page document, which is useful for large PDFs or TIFF files. Moving to the second statement, this is false because merged cells do not stop the layout model from extracting tables. The layout model is designed to handle complex table structures, including merged rows or columns, and still return usable table data. Next, the third statement is false because key value pair extraction does not depend on entity extraction. These are separate capabilities. A document can return key value pairs even if no entities are defined or detected. Finally, the fourth statement is true because the layout model can return row and column indexes for table cells, regardless of whether header rows exist. This allows applications to understand table structure even when headers are missing or unclear. Question 60. Which file must be included in the blob container to describe all labeled fields for extraction during custom model training? Select one answer. A. Fields.json. B. OCR.json. C. Labels.json. D. Config.json. The correct answer is A. Fields.json. Now let's work through why that is and why the others don't fit. Option A is correct because fields.json defines the complete list of field names that the custom model is expected to extract. It acts as the schema for training, and every labeled document in the training set refers back to these field definitions. Without this file, the service does not know which fields it should learn to extract. In contrast, option B is incorrect because OCR.json only stores the OCR output for individual training documents. It contains detected text and coordinates, but it does not define which fields are being trained. Option C is incorrect because labels.json maps field names to their bounding boxes on each document. It relies on fields.json but does not define the master list of fields itself. Finally, option D is incorrect because config.json is not used in Azure Document Intelligence custom model training. It does not participate in field definition or labeling workflows. That is why fields.json is the required file for describing all labeled fields during custom model training.